Your speaker is Peter Thomas, Senior Engineer with Resource Compliance. He is both the President and the Senior Engineer. He has extensive knowledge of chemical safety regulation with particular emphasis on ammonia refrigeration and process safety management. He has a degree in mechanical engineering from Cal Poly San Luis Obispo, and is a licensed professional engineer. Peter?
Okay, good afternoon. Well, welcome back after lunch. I think I recognize a lot of the faces from the morning, so I'll kind of reintroduce myself again really quickly. I'm a mechanical engineer, as she rightly said, and our company does a lot of CalART programs, particularly in the San Joaquin Valley. That's where we're located. And I'd say probably 80% of our clients are ammonia refrigeration. So that's my background in terms of college and schooling, and that's kind of our focus, although we do other chemicals. This particular presentation is titled Ammonia Refrigeration Ragagep. And while I am going to define what Ragagep is, if that's your first time hearing that acronym, this class will probably be a little bit confusing or above your head, I might put it. So I just want to put it that way. This is more of an advanced class that's going to get into the nuances of ammonia refrigeration and code compliance issues. I'll also say, as a way of introduction, that I have probably too many slides to get through during this presentation. So thankfully, this will be available on the CUPA website as well as on our company's website, resourcecompliance.com, even later today so that you can access those. And finally, you're going to see a lot of code references on the slides where I've actually taken snippets of codes, put them on there with chapter and verse. I have not done that so that I can bore you by reading them to you. I've done that for your reference so that when you download the presentation, if you do so, you can refer to them. I'm kind of not a fan of too much text on a PowerPoint, but I've done that in this case. But that's for your guys' reference looking back at it. Okay, I hope that makes sense. So there'll be slides with a lot of text where I might mention a few things, but I promise you I will not read those to you. I especially won't read them to you directly after lunch when everyone's going to already be struggling a bit. So, and as I did in the last class, I'm going to give a short 5-minute break about halfway through the presentation just so people can stretch their legs, because I know an hour 45 is a long time just to sit without moving. Okay? So without further ado, one more point that just came to mind. Because this is a recorded session, if you have a question, I would ask that you walk up to the microphone and say it so that it can be picked up on the sound. If you're too shy to do that, I will allow you to just say the question and then I'll repeat it after you. So don't think I'm being weird by repeating your question, but that's so the camera picks it up and everyone on the video can benefit from that. Okay? So where does the term Ragagep come from? I'll be honest, as I began a career of process safety, I somewhat fought the term. I didn't like it. It's long and it confuses people. I mean, acronyms shouldn't be 7 letters is my kind of theory, but it's too important and too common now to fight it anymore. So now I'm just giving presentations at the CUPA conference on it. So Ragagep comes straight from the CalART regulation. It's also in PSM and RMP, but since we're at a CUPA conference, we'll say it comes straight from the CalART regulation. I'm going to show you in your guys' rules where that is. First, process safety information, 2760.1. It says the owner or operator shall document that equipment complies with Ragagep, recognized and generally accepted good engineering practices. Another instance occurs in the mechanical integrity subsection, 2760.5, where it says that for your mechanical integrity program, inspection and testing procedures shall follow Ragagep, recognized and generally accepted good engineering practice. So if you leave this class learning one thing, I hope it's you learn what Ragagep stands for. So I think as a CUPA inspector, it's important that you know what the acronym means. I've the second bullet point up there where it's not the full Ragagep, but just good engineering practice in relation to the frequency of inspection and tests. So again, pointing to this important concept. And finally, one other somewhat subtle reference to, in my opinion, to Ragagep is in the pre-startup safety review, the PSSR subsection, where it says construction and equipment is in accordance with design specifications. You might think to yourself, well, I don't see Ragagep jumping out of the page at me, and that's accurate. But 2 slides ago, we looked at process safety information. You must document that equipment complies with Ragagep, right? And therefore, when something is being designed in terms of the pre-startup safety review process, design specification shall be Ragagep. From that, it's kind of a connection there. Okay, so that's my case and my kind of an introduction, my case of why Ragagep matters. I think I maybe overheard even a conversation before this presentation started by a couple of inspectors, I take it, that said, are Ragagep's really enforceable? Like, can we really, are these as heavily weighted as, let's say, maybe a law is, the straight CalARP regulation? I'm going to show you just a few slides of these are all within the last 18 months where businesses have been cited on a Ragagep issue by OSHA or EPA, thousands of dollar citations. So here's the first. Employer did not document that equipment complies with Ragagep. If you read this paragraph here, this is particularly regarding the machinery room ventilation system, and the amount of penalty was $7,000. So certainly the machinery room ventilation system, Ragagep, was important in this instance to OSHA. Another example, you can see the penalty here, $4,500, and this, again, if you look at it, it's broken down into several points. Pressure vessels, ammonia detectors, and the remote actuation of the ventilation system were all cited in an OSHA, in this particular violation, as a Ragagep issue. And when I say as a Ragagep issue, what I mean is when you look in the CalARP regulation, you will not find a section that talks specifically, let's say, about remote activation of the ventilation system. Not there. It's not in the CalARP regulation. What's in the CalARP regulation is a reference to equipment complying with Ragagep, which this particular inspector pulled out during their visit. Okay? A couple more examples. Again, I'm just making the case here. We're not studying these, but I'm making the case that, yes, Ragagep is enforceable, and it's actually very common to be enforced. Here's another one, $6,300, where the ammonia engine room doors were not proper. Okay, notice it's talking about the garage door leading was not equipped with tight-fitting seal, and they were cited under the process safety information subsection as a Ragagep violation. Okay, this next one was a pretty famous one in the news quite a bit, and in fact, many of you may have seen the Chemical Safety Board investigation of the Millard Refrigerated Services leak that occurred, that released in excess of, I believe, 30,000 pounds of ammonia. I don't remember the exact number. And Millard reached a $3 million settlement with US EPA related to this particular event. So it was a big deal. And while not all of the citations were Ragagep, some were. If you notice here, this is count number 18. There was a lot of counts, by the way. They pulled up a lot of things, but was in fact related to Ragagep issues. If you quickly scan this with your eye, you will notice references to IAR Bulletin 14. That really should be 114, but it says Bulletin 14. IAR 2. You see references to U1 and U1A and U2 forms. All of these are associated Ragageps for various aspects of the refrigeration system. Again, the total citation here was over 3 million. It wasn't broken down by count, but this was part of it. Okay. A couple more, let's go quick. Here's a $5,500 one. Again, a Ragagep. This is related to labeling of pipes. You can see industry documents, again, Bulletin 114, and ANSI 813. These are pipe labeling standards, industry documents that were cited as a Ragagep violation. Okay? Here was a consent order. This was, again, a pretty pretty famous one. I'm just showing you here that they did not document, according to EPA in this case, that the process complied with Ragagep, and therefore they were fined a penalty of $385,750. Now this was settled for quite a bit less, but this was the initial penalty that was stipulated. Okay? So certainly, I hope that made the case. That these kind of slides certainly wake end users up, the facility people, to the importance, and that's really why I use them. It's not really fun to use scare tactics to get people into compliance, but I want them to understand that, yes, Ragagep is important. It's such a critical idea because our CalARP regulation is a performance-based regulation, and that means there's some flexibility in how implementation is done. If I were to ask you, and this is a good thing because it addresses all chemicals, right? All chemicals that are regulated by the CalARP regulation. And instead of defining the frequency that events need to take place for maintenance and inspection, they are kind of punting and giving the flexibility to use what industry consensus has defined. So in light of that, I'm thankful that it's written that way. But the flip side of that can be a lack of clarity at times. There can be competing Ragageps that confuse people. There could be incorrectly applied Ragagep. So a Ragagep for a certain industry tried to apply to the wrong industry can create problems and not be the right fit. And I just throw this slide in here regarding the general duty clause. While it doesn't say Ragagep, the general duty clause, as I know you guys as inspectors are familiar with, this is OSHA's general duty clause, but EPA has theirs as well, says that employers essentially need to furnish a place of employment that's free from recognized hazards. How do we know what's a recognized hazard? You know, it's going to be because there's a consensus amongst codes and people and industry groups that something has been deemed hazardous. So even within the general duty clause itself. And I've been part of EPA inspections for CalARP Program 2 facilities, meaning they're less than 10,000 pounds. Okay, so they're not even subject to the full provisions of the Risk Management Program Rule, Title 40, Part 68, yet the EPA can still inspect under the general duty clause and will then use Ragageps under their authority in the general duty clause. Okay? OSHA has recently, I say recently, it's about 6 months ago, released a memorandum to their personnel, but they made it open to the public, clarifying how they want Ragagep to be interpreted. I would encourage you to, you can download that from the OSHA website. We actually have it linked on our website as well where you can find it through a simple search. Here's some of the highlights in this Ragagep memorandum. A differentiation between the words shall and the word should. So OSHA is telling their inspectors if a Ragagep document says something shall be done, there's an expectation that is going to be done. That's industry consensus saying it needs to happen. Versus if the document says it should be done, that opens the door to more flexibility and wiggle room to not do it, but instead do it in maybe an alternate method. Okay? Similar with normative and informative. So a normative requirement is something that is meant inside the document to be required. So it means that the basic minimum requirement is contained in that section versus an informative section, a section that's clearly labeled as informative is not intended to be implemented as an enforceable issue. Okay? Now, let's just pause for a second because I didn't become an engineer or learn about anything like this in engineering classes, right? This is more like law school. Similarly, most facility managers or refrigeration technicians have very little interest in slicing and dicing sentences to determine like what's shall and what should, what's normative and what's informative. So I would say this is just an unfortunate reality of the world we live in terms of how we have to carefully use language. But luckily, as industry is catching up, private industry, I mean, in terms of even writing these documents, we're carefully selecting the sentences that we put on paper so that we're not being unclear, okay? And I'll talk a little more about that in terms of my experience being on some committees with IIAR, okay? In addition, OSHA talked about the primary sources of Ragageps, which I'm going to talk about in a couple of slides, and the use of internal standards. Just a note on that. So they do allow for the internal use of standards. I would suggest, aside from the very large corporations, most businesses are not going to be writing their own internal standards that would be then replacing Ragageps. Most are not staffed to that nature, so I'm not going to spend time in this presentation to discuss that, okay? So what is the key ammonia refrigeration Ragagep? First, Ragagep organizations, okay? I'm going to highlight a few that as CUPA inspectors, I think it's important you're familiar with. Okay, they're shown up here on this screen. The American National Standards Institute, that's ANSI. ANSI is an accrediting body that is not standalone in terms of specifically related to hazardous chemicals in any way, but they're an accrediting body that standardizes the documents written by organizations so that they fulfill some basic requirements in terms of they've reached a consensus. They're not like, they weren't just made up by people in New York, let's say, or just in California, but they've had input from the public and so forth. The next three that are listed there, ICC, IAPMO, and the CBSC, these are building code commissions that write what are often called model codes. So someone might talk about the fire code or the mechanical code or the plumbing code. All of these organizations are responsible for writing codes, and then those codes get applied to various jurisdictions, and that's an interesting topic in and of itself. And then we've got ASME, the American Society of Mechanical Engineers, that has a real emphasis on pressure vessels. That affects our industry quite a bit. ASHRAE, which was formerly the American Society of Heating, Refrigeration, and Air Conditioning Engineers, but now they're just ASHRAE, but they have some standards that affect our industry. And the most important, I saved the best for last, I think, is IIAR. This is the International Institute of Ammonia Refrigeration. If you ask me what's the most important Ragagep writing organization for ammonia refrigeration, I wouldn't hesitate to say IIAR. If you want to familiarize with one, I would advise you to familiarize with IIAR. Again, if I'm speaking to a room of chlorine operators or sulfur dioxide operators or even ammonia fertilizer application, I'm not going to say that same sentence. Ragagep is particular to the industry. Okay, it changes industry to industry. Okay, it's not even specific to the chemical. So there's different Ragagep organization for, let's say, fertilizer ammonia versus refrigeration ammonia. So you'd go to the Compressed Gas Association for a fertilizer application versus IIAR for refrigeration. Okay, a little bit about IIAR. This is just a plug. I am a member of IIAR and fairly involved I'm a corresponding member for the standards committee, but IIAR notice has a mission. One of the elements of their mission is to create standards for the benefit of the global community. So that's even inherent to their mission as an organization. Now moving from the Ragagep organizations, that was the previous couple slides, to the actual documents. Okay, here are some very key Ragagep documents that you want to probably be familiar with. The California Mechanical Code, and in particular, it's Chapter 11 that has the requirements for refrigeration systems. This is the CUPA conference, so you're all interested in California, I know. I've also put here under it the Uniform Mechanical Code. The California Mechanical Code is a derivative of the Uniform Mechanical Code. What does that mean? It means that they took the Uniform Mechanical Code, adopted it, and made very slight modifications. So good news for you as regulators that have always, you have limited budgets. There's always budget cuts, it seems like. Everyone's always talking about budget cuts. The California Mechanical Code is free online. So you can download it, no cost. You can download each chapter. and it's a PDF, and I don't think you can print it, though. I think they keep you from printing it, but you can download it. And so you have that available to you at no cost, okay? Same with the California Fire Code. Now, the California Fire Code is a derivative of the International Fire Code, not the uniform code body. So this gets a little bit confusing at times to people because there's competing model code organizations that write codes, and then California adopts their own mechanical and fire codes, but they don't even adopt those codes from the same code writing bodies, if that makes sense. They pick fire from one body and mechanical from the other. So if you're confused, so is everybody else. Okay, so it's kind of in that sense, it's kind of a confusing document or a confusing subject. Now, sometimes I like to try to make it. Well, I always try to make it simpler. I hope that's what I'm attempting to do here. And one you might ask or be thinking to yourself, if I can just have one document, if you were to emphasize one document that would give me the most Ragagep information for ammonia refrigeration, what would that be? And again, without hesitation, I would say the document is IIAR-2. Okay, IIAR, that's the organization. That's International Institute of Ammonia Refrigeration, and they number their standards 1 through 8. So I'm recommending number 2. If you have a limited budget, just buy number 2, because that is the design. I should have updated this slide actually, because this slide says equipment, design, and installation of closed circuit. Actually, the most recent version, which was just released, it says 2014, but in fact it was released in 15. They put a 14 date on it for reasons I won't go into, but it's actually design, or installation should be scratched from that title. It's just the design document now. So it's the Ragagep document that covers the basic minimum requirements for designing an ammonia refrigeration system. And this document's existed since at least 1974, and it's gone through all these modifications. You see the covers there, and every single aspect of this document applies to ammonia refrigeration, and that's why I would recommend it versus other documents where you have to pick and choose or make a determination as to what is applicable versus what is not. And many of the things we reference as consultants when it comes to Ragagep come straight from what was this document until very, very recently. Within the last 2 months, we've got our hands on this new IAR-2 document. Okay, other critical documents that you need to make sure as a CUPA inspector you're familiar with, and you've probably heard of these terms if you've been in the industry long, but these are IAR Bulletins 109 and 110. Now, on the previous slide, I told you the most important is IAR Standard 2, and now I'm talking about Bulletin 109 and 110. When I say standard or bulletin, there is a different connotation. There should be a different connotation in your mind. A standard was written by IAR with the understanding that it would be enforced as a Ragagep worthy violation by OSHA or EPA or you folks. The bulletins were not written in that way. The bulletins were written by industry. Many of these were written in the early 1990s to serve industry without the, maybe even pre-PSM. Some of these might have been written pre-PSM. I don't know the exact date. So they were written as a tool to industry, not understanding necessarily how things would progress in the regulatory climate, and then now these things would be getting enforced. So as a result, we are working hard. When I say we, I'm talking about IAR, working hard to develop Standard 6, which will essentially retire Bulletin 109 and 110 forever. Now that will be hard for the industry vernacular to catch up because the B109 rolls off the tongue of a refrigeration tech. This particular document here, I think that's 109 there. Yes, this is 109. It has 10 checklists in the back of it, and those checklists have become incredibly popular and well-known. They're great checklists, and they're kind of the bedrock of a refrigeration system mechanical integrity program. But again, the intention of IAR is to retire these documents because they were not written as standards. They weren't written necessarily comprehensively with every requirement in mind, or maybe in some cases they mentioned things that now looking back at it, it's like, I didn't really mean for that to be a penalty by EPA or something if that wasn't enforced. So I'm a member of this committee writing 6. So we do a weekly 2-hour conference call where people from all over the country are participating. It's a good experience. And then when that document's ready, it will go out for public review. And public review can go through it can take a while. So I think the best case scenario is that IAR 6 would be finished at the end of this year, but maybe even into next year. That's just my own personal prediction. We'll see. But this will be a critical PSM CalARB document because it will cover the maintenance. It's the standard for the maintenance of ammonia refrigerated systems, which will mean mechanical integrity programs and protocols. Question?
So will the language be shall and not should?
The question was, will the language in IAR 6 be shall and not should? The answer is resoundingly yes. And in fact, each chapter next to the chapter heading either says normative or informative in parentheses. So normative means required, informative, and the informative, by the way, is reserved for appendices. So there will be informative things in the back of the document like sample checklists, but they'll be specifically stated to be informative, meaning we're not trying to prescribe that this particular checklist has to be used. We're giving you an idea of what the checklist will be used. But to your point, if the document in the normative section ever says should, we messed up. We didn't proofread it right, okay? So it should not say should or some nebulous word that leaves subjectivity. It should say must or shall, or not say anything at all. So just not address it. So that would be the correct approach. We want to remove opportunity for confusion and error. So for example, in the previous standard of IAR 2, even when this wasn't fully thought through, a previous standard, it said eye wash and shower station shall be located outside the refrigeration machinery room. That's clear language. But then it said, as a note, but it's also recommended that you install an additional one inside. So it left somewhat nebulous. So it was okay, I definitely need to do this, but apparently I don't need to do this. However, how's OSHA going to look at that? It's going to be if you don't do it, are you cutting a corner? The new document, new IR2 says just clearly needs to be inside and outside, both. So it's we're trying to be just more clear. Leave less white space, as I put it. You got the text written here. The space between the line, that's the interpretation. We want to hopefully remove that and come to a point of consensus as an industry. Okay, so the bulletins, I already said this, but they were written in a way where they were less binding in terms of their nature, yet they've been, you saw in the violation slides, Bulletin 114 was cited a bunch of times, even though it wasn't the intention of industry, of our organization, for that to be the case. Whereas standards, in each standard it says this document is intended to serve as a standard. It's clearly our objective from IAR standpoint to write this as a standard document. Here's the suite of standards IAR's developed. All the ones in black text are complete, are written, published, and available for purchase on the IAR website. As a member of IAR, you can download them for free on these, okay? So the membership's fairly expensive, but you're available to download these if you're a member. So that's something to consider in terms of an agency. And as I mentioned earlier, 6 is not yet finished. So that's the only one at this point is still in development. And Don Tragathon rightly brought up to me prior, he asked if I was going to mention the training guideline that IIAR and RETA, and I believe the Association for Refrigerated Warehouses work together to develop. I don't have a slide for that, but it's a good time to plug it. There's other documents that have been written for industry to serve as guidelines that can be that really serve when you're developing a training program or something, would be considered a Ragagep type of document. Okay? That was a flyby of a bunch of Ragagep information, organizations, documents, etc. And I bet it was a little bit confusing. And now the next 3 slides, I want to show you, I want to illustrate why the topic of Ragagep confuses both you folks, CUPA folks, and other regulators, but also end users. It confuses people immensely. And let me just quickly demonstrate. In my opinion, the California Mechanical Code, when, let's say, designing a system, if you're in California, of course, is kind of the premier. This is my opinion. This is Peter Thomas's opinion. So someone could disagree, and that's fine. But it's kind of the premier document that should be followed. But as you can see in the California Mechanical Code, it clearly points to that systems also must comply with ASHRAE 15 and IIAR 2 if they're an ammonia system. Okay, so by reference, our single Ragagep, if we started with CMC, California Mechanical Code, has branched off to 2 new Ragagep documents, right? IIAR 2 and ASHRAE 15. So for an example, look at IIAR 2 now. IIAR 2, in talking about pipes, it says, and the types of metals that are used, says you must use the types of steel, et cetera, that comply with ASME B31.5 and the Boiler and Pressure Vessel Code Section 8. So remember, we started with California Mechanical Code. It branched 2 directions. Now IIAR 2, in this instance, has branched to 2 more potential, the 2 more Ragagep documents. Okay, so, and you can do the same here regard to eyewash stations. It says they need to comply with this new document, another Ragagep document. Later in IIAR 2, it refers to NFPA 704 and the Mechanical Code. In ASHRAE 15, it refers to some other Ragagep documents. So what we're left with, let's look at this from a diagram standpoint. We started by just looking at CMC as our first Ragagep. It branched to IIAR 2. It branched to ASHRAE 15. Those 2 documents, IIAR 2 branched to Boiler and Pressure Vessel Code, Section 8. ISEA Z358.1, which is the eyewash station standard. NFPA 704, which references the International Mechanical Code. And similarly, ASHRAE 15 takes a similar approach. Okay, so this is why this is such a confusing topic and why it's a difficult topic. You guys are all familiar probably with the Russian nesting dolls, those wooden dolls where one is inside the other, is inside the other, is inside the other. I once heard at a talk, and I kind of have stolen the idea several times, but that's how Ragagep documents work. It's like a Russian nesting doll. You open one, it goes to the next, and you open the next, and it goes to the next, and you just keep going, and I'm not sure it ever ends. Looks like we have a question. Yes?
Don't all these codes sometimes conflict with one another, or is there none of that either?
No, the codes, unfortunately, at times there is tension between codes. There will be I'll use that word, there'll be a conflict or there'll be a different requirement. I will say for refrigeration systems, that's not that common. But for an example, the California Mechanical Code currently, I think it's going to be changing those soon, but has a different equation for sizing relief valve piping compared to IIAR 2 in the International Mechanical Code. So there are conflicts, yeah, and that's where a design engineer comes in. You know, a reputable design engineer and why things go through plan check. So I think, and again, CalART program, process safety information, you're supposed to be stating design codes and standards employed. I don't know of someone who got cited because, like a violation, because they documented that their relief piping was designed according to, let's say, the IIAR 2 piping equation, and someone wrote down, nope, it has to be the California Mechanical Code equation. You know what I mean? So there are conflicts, and that's unfortunate. I'll say this for IIAR. IIAR has a gentleman named Jeff Shapiro, and he's paid by, at least in part by IIAR, to sit on code writing bodies for the sake of our industry to try to do away with that kind of stuff, to try to do away with these differences. So, and he's been pretty successful at making, we want the requirements for everything to be the same. Across America, really, that would be our desire. So, but it's a good point. And unfortunately, there are some cases where there are conflicts. okay? So that was kind of the theory behind Ragagep, or you might even say a long introduction, but I think one that's necessary for you as a CUPA inspector if your intention is to apply Ragageps. And now the remainder of this presentation will be what I'm calling the implications of Ragagep. So what are the Ragageps for ammonia refrigeration system? So what is required? Now, if I were to guess, you all know a lot of refrigeration Ragagep. So for example, I'll pose a question to the crowd. How often must relief valves be changed on an ammonia refrigeration system? 5 years. I heard a lot of people answer. You know that. If I ask you, well, how do you know that? Where is that written into your CalARP regulation or your RMP regulation? If you'd have to say, well, it's not. What is that? What's Ragagep? That's what industry literature says. That's what the manufacturer's recommendations are, and that's in Ragagep documents. So when facilities push back on Ragagep issues, it's usually simply due to lack of information, because they don't push back on relief, generally speaking. They don't push back on relief valve replacement because that has been effectively communicated over a long period of time that that's a requirement, and so they kind of know. The problem is a lot of the other requirements are not so well known or haven't been effectively communicated, and so they're surprised by them when they come up because they weren't aware of them, or maybe it was not even included in the original design of the process, and they thought they had a code compliant, you might say, a code compliant system, when in fact maybe it missed certain key requirements. So we're going to jump through a variety of topics here. I mentioned this. I'll say it one more time on my slides. The purpose of the text here, these snippets from codes, is simply for your reference. So all of these bullet points that end with a bracket and some code reference are directly taken from a code. I have not modified them in any way, and I'm not going to read them to you. I'm going to probably have a slide or two with this text, and then I'm going to follow that up with pictures to more talk through the concepts. So the first Ragagep topic that's kind of that I want to discuss is that of safe access being provided to equipment that's part of a ammonia refrigeration system. Okay. As you can see from these snippets from the mechanical code as well as IAR2, there are a variety of requirements that openings be certain sizes to get to valves, compressors, etc., as well as just general equipment accessibility needs to be provided. The basic idea is you can't maintain a system, you can't respond to an emergency if equipment can't be accessed. Okay, the new version of IAR2, again, the one recently released, seems to have a heavy emphasis on this. It stood out to me, which is why I started with this. It stood out to me where it seems to be a heavy emphasis. And honestly, as a consultant, I kind of like that because often I think, wow, you got this brand new system, but man, you put that vessel right there and no one's ever going to be able to get to it, or it's located in such a way that they're going to be less likely to maintain it because you're going to have to get an extension ladder and it's just not comfortable. And so in each subsection of IAR2, when talking about individual types of components, it's specifically referenced maintenance accommodation, so providing accommodation access for maintenance. This goes a long ways in a safe system, in responding to an emergency, and in doing a mechanical integrity program. It's very hard to maintain equipment that you can't access. You can even think about this at your home, okay? If you do maintenance at your home on your air conditioner, let's say, if it's on the roof versus on the ground, which are two different styles of install, you're probably more likely to take a look at it more often if it's on the ground versus having to climb up on your roof, which increases the level of danger and work and effort. So I've got a few pictures here showing a couple of good examples. Here's an older engine room, but very clean. You could see pretty good aisleways in between equipment. And this one's an excellent engine room. Very clean, wide aisles, clearly marked areas, practically could eat off the floor. And then here, this is a roof of a refrigerated facility that not so good. It was like a pipe jungle on the roof. No crossovers. You had to climb over and under pipes and conduits and fiber optic cables to get from one point to the other. A real nuisance and really cuts back on the ability to access the equipment. It's worth probably mentioning this particular picture right here was actually taken from a facility in Mexico. So we've had an opportunity to work with a client in Mexico, and it's been kind of a cool experience for us to see that in a lot of areas, they've been a lot more willing, a lot more eager to do the right thing. Now, I'm not saying that's a blanket. We've only worked with one company that has about 7 sites throughout Mexico. Maybe they're unique. But where we seem to see more resistance here in the States, and maybe in California, a feeling of maybe being overregulated or something. In Mexico, there seemed to be more of a desire because they're hiring us to provide this consultation without it even being required. And then you can kind of just even see the nature of their machine room before we got there. So it takes resources to have a room like that. It doesn't happen on its own. If you don't throw any resources at it, over time it'll end up just looking like this. You'll just patch things together and it'll end up in that way. Here's another example. It's kind of a cool picture, maybe not too applicable to most areas of California. This was taken out of state, but a site we went to where it snows a lot. I think this was in Wisconsin. Okay, Wisconsin, how do you provide safe access to your evaporators? You know, up here in California, often we'll put equipment on the roof. It's very accessible, very safe. But if you've got a roof covered in snow and ice, that may not be safe anymore. So they built a penthouse to store the equipment. What a great way to provide safe access to equipment given that environment. So a specific environmental concerns or consideration should be taken when thinking this through. Penthouse wouldn't necessarily be necessary where we are, but there it was. Valves need to be accessible as well. Okay, and in particular, again, I'm not going to read the codes, but valves need to be accessible via. Notice what it says: from floor level, a portable platform, a fixed platform, ladders, or be chain operated. So there's several means available. Not every valve needs to be operable from the ground, but they need to be operable from one of those 5 options. However, if it's part of an emergency shutdown, let's say the king valve on the receiver, you now notice what's been removed from this list are the portable means of accessing the valves. So you're left with only a permanent platform or a chain, from the floor, permanent work surface, or chain operated. And when I say chain operated, I have a picture here. I have a picture of a valve that is not chain operated, but is a good candidate for a chain, which this is, I know it's kind of hard to tell, but that's probably about 15 feet in the air on the suction accumulator, shutoff valve, and where you can attach a chain operator with the chain hanging down. Now, I know a lot of mechanics aren't huge fans of chain operators. They're not as good. They slip occasionally and so forth. But here's another example, some valves that are just suspended in space in machinery rooms that are very, very difficult to access. Here's one. Again, I wish you had more perspective, but this is a hydrocooler, okay, flooded arrangement. This is the suction pipe going back. Now, this is the suction pipe here going back across this roof, and there's the isolation valve. It might look like that valve is on this other roof, but it's certainly not. That valve is like at least 10 feet off the roof and just suspended in space again. So probably even higher than a standard extension ladder would go. Really high, probably 30 feet in the air. So to access that valve, you'd really need like a scissor lift or something. So it's just unfortunate that the valve wasn't here or a little bit further this way, all the way onto the solid permanent work surface. So just things to look for. Question?
So in the previous couple slides, you identified that the new IIAR2, NC2, in 2014, identifies the third bullet down. They're going to have to be
Yeah.
a little bit more ground operated or something motorized, that kind of stuff. The difficulty we have with a lot of Ragagep is how do you apply that to an existing facility that may have been there 10 years, 15 years, 50 years? And all these different codes have come in since those times. So the way I look at this is that's great for any new installation or new building, but you can't retroactively apply it to everybody that you may already have. Is that correct?
Yeah, that's a really good question. Something that comes up a lot, and I know exactly what the end user says to you guys as CUPAs. They say, no, you're wrong. We're grandfathered, right? That's what they tell you guys. They say, we're grandfathered. And what I would encourage, and I tell our own clients this, you can say you're grandfathered, but you better know who your grandfather is. So you can't be grandfathered to nothing. There's no such grandfather. So if you're going to claim, no, I have a grandfather, then you should know it. This goes back to design codes and standards employed. So I think where it's I think there is tension. So here's my approach. I do not think, here's what I don't think. I'll do two extremes. I do not think that when the new IAR2 comes out, that you or me or anyone else should go to a cold storage facility and say, you must upgrade to be 100% compliant with IAR2. I believe that is not the intent of the document. And in fact, it specifically says in certain areas not to do that. So that is not the intent of that document. But likewise, I do not think it's the intent either that someone says, well, my facility was built in 2013, therefore I don't give a rip about 2014 IAR. Because what is the document? It's industry consensus. So industry has come together and agrees on these basic things. So where I think it's valuable, where I think you have some flexibility, me as a consultant, you folks that are in here as end users, and you as regulators, is like during a PHA hazard review, that's where you have what-if questions, right? What-if questions that are going to say, well, what if such and such a thing happens, and then it becomes clear, well, maybe we wouldn't be able to access that valve. And then that's when it becomes useful to be able to say, well, the most current version of like this industry document, is more clear on this topic. So it's a really good question. It's a really common question. I don't think people, I don't think people should be kind of beaten over the head with the newest documents because they are always changing. But on the same hand, you can't ignore, for example, like a few slides ago, let me go back on this one, there's a heavy emphasis in our industry on maintenance accommodation. That's just the bottom line. Maybe it wasn't there 5 years ago, but it's there now, and you need to think about it too. It comes as a result of accidents that have occurred and so forth, and we want to, as a group, learn from that. So, really good question. Okay, catching myself back up to where I was. Machinery room, another special access consideration is just to the machinery room, and sometimes our access considerations are in the negative sense, meaning we need to restrict access, okay? And that's the case for a machinery room. Ragagep says machinery room access must be restricted to authorized personnel only. Needs to be signs on the door that say so. There should be permanent signs that say who the room, that only authorized personnel are allowed to enter the room. Often get asked the question, does the room have to be locked? And the answer is the code is not clear. There's not a clear definition that it says it has to be locked. I think it's a matter of a judgment call. Putting a sign up that nobody listens to is not effectively complying with the intent of this section. I will say that. Okay, so putting a sign up and saying I'm compliant, even though people still cross through the machine room on their way to whatever, the parking lot, that's not acceptable. But there is flexibility to use administrative and engineering controls both. Okay, so here's a few examples of signs and what you might expect some good and some bad. This sign was kind of designed out of the IAR2 appendix, the informative appendix, which has the NFPA and the correct caution labels. This door is lacking a few. This was an outside machinery area that was fenced in, which is okay. However, they removed the gate altogether. This was an interesting one. Out of fear there was a rumor of some an ADA disability person who was coming around trying to catch businesses that weren't ADA compliant with access, like to wheelchairs. And so some other HR consultant came to them and said, hey, get all your, if you don't have wheelchair access to a certain area, you need to remove doors, like to get them out. And they did that for the machinery area, and I informed them, I don't think that's applicable because they shouldn't be going into that area anyway, so that was taken too far. But sometimes even you face like competing regs at a time, that was a unique circumstance. Speaking of doors, here's a door that didn't lock, okay? It was a damaged door. This was an issue. You could see even the hardware on the door had been removed, right? And so you can't restrict access really without a lock. Well, in certain instances, you cannot restrict access without a lock. So even the hardware on doors matters often, as you saw in some of those citations earlier. Okay, now changing topics to nameplates. This is another Ragagep topic that is a pretty big deal in our industry. Here's a whole bunch of code areas. Again, each section of the new version of IAR2 has nameplate requirements, and I've listed those different sections there. So chapters 8 through 16 are basically on different types of equipment, and each one requires there to be a nameplate. This is what the boiler and pressure vessel code comes to. Unfortunately, I get asked quite a bit, what do I do if a nameplate falls off the vessel? I don't have it anymore. And I always answer in this way, unfortunately, I have no good news for you. There's no good news for that situation. I might look at the vessel and it might not look badly corroded, but there essentially is no proof at that point that the vessel was safely designed or constructed or is appropriate for ammonia. So it doesn't happen a ton in refrigeration, but it's more common in fertilizer, like nurse tanks, a lot of nurse tanks without nameplates. Here's a few pictures of just what you expect a nameplate to look like on a pressure vessel. RVS is a very common vessel manufacturer in ammonia refrigeration. Here's a nameplate that is painted over, so really hard to read. I run across that quite a bit. It's unfortunate. Luckily, paint can be removed usually, but we see that quite a bit. And here's a nameplate I particularly like. It's a local manufacturer for us that really puts a lot of good information on it, but it's above and beyond even what's required. Their company is a Ransom, they're called. Let's take a closer look at a nameplate. I'm going to walk you through what are the absolute minimum requirements on a pressure vessel nameplate. The first is the ASME stamp. Okay, if you're going to look for one thing, look for that, because that little clover with the ASME inside of it is an indicator that it's an ASME vessel. Okay, it's not the only thing to look for, but it's a good place to start. We once saw a shop fabricated receiver, believe it or not, like a 24-inch pipe with heads, and didn't have a nameplate. It was just made out of pipe, and then said, well, you don't have a nameplate, and the contractor came and put some house-made nameplate on it. Well, that is not fulfilling the requirements. Bottom line, it was not made according to specs. By the way, I'll point out the nameplate is supposed to require destruction to be removed. And notice it does. It's usually riveted on or welded on. In this case, it was welded. Here it's riveted to a plate so that it doesn't like just fall off. It doesn't unbolt. It actually requires destruction, which makes it hard to do. Okay, beyond the stamp, it should have the certified person that made the vessel. Should have the maximum allowable working pressure at a corresponding temperature. Okay. It should have a minimum design metal temperature. That's the MDMT, the minimum design metal temperature at the corresponding pressure. And these pressures, the maximum allowed working pressure and the minimum design metal temperature corresponding pressure are the same. It should have a manufacturer serial number. And notice I'm walking through this on both these because each manufacturer's plate might look different. It might be oriented differently, and that's totally fine. And then a national board number if it's registered with the national board, which is obviously really handy so that you can obtain information if you have a falling out with your contractor, or they're no longer available, or they want to sell it to you for several $100s when it should only cost $26, okay? So if a data report is registered with the National Board, it costs $26 per page. Make sure people know that, because there are some people that try to sell them for $200, I guess just because they can, but that's unnecessary. A lot of manufacturers give them to you too, so it's just kind of a difference in philosophy. Oh, and then finally, a stamp with a W. This one has an RT4. This is an indication of the type of welding radiography that was done on the weld. So I have it here. Like a W indicates that it was arc or gas welded. You could see a P or a B for braze, or a RES for resistance welded. And the RT here, RT1 through RT4, RT1 is the highest level of radiography, like full radiography on all the welds, versus RT4, which was partial spot radiography done on the vessel. Okay, here's a couple of bad nameplate examples that you might see out there. Just really bugs me, but Frick always does this. Frick is a compressor manufacturer. They still do it. I just took this. They put their caution sticker on top of their nameplate for the oil separator. And of course you can remove it, but it doesn't just like peel right off. It's one of those like terrible stickers that you have to get your fingernails or some adhesive remover. So, it shouldn't be covered. Here's what happens over time when you have a really, really lousy vessel that's not maintained, and then I'm up doing a mechanical integrity inspection, I grab it, and it just pulls right off. So I just sat on the top and took a picture, but obviously this thing is toast. And this one, you might have a hard time even seeing, but the nameplate, unfortunately, the contractor put the float column, this is on a surge vessel, put the float column right in front of the nameplate. So it's like 1 inch in front of it, so I could see that there is a nameplate, but you can't read the information. That's just unfortunate, because there's nothing at this point you could do about that, minus removing the float column. Now, I would not make the recommendation to move the float column, because I could see there was a nameplate, and they had the data reports. But come on, don't do that in the future. Like, let's make a consideration so that there's a nameplate for a reason. You want to be able to see it if it's requested, my opinion at least. Yes?
Is it okay if they remove the nameplate and relocate it to another area? Is that allowable?
The question is it okay to remove the nameplate and relocate it to another area? And the answer is no, it's not okay. It might be okay in common sense. If the nameplate, like in this picture here, is like extended from the vessel, I'm just talking in common terms here, it won't do any harm to the vessel. Like, it's not going to derate the vessel. But I have looked into that exact issue for someone that did that, and that's why it says the nameplate, even moving the nameplate, shall require a revision stamp on the vessel. Okay, then that's okay. Yeah, so if they went through, that's just a lot of work to go through to move it. But you can order nameplates or vessels with duplicate nameplates. Certainly recommend this. This is pretty common now. If it's an insulated vessel, get the nameplate protruded out so that it doesn't get covered by insulation. Doesn't happen too much anymore, but happen a lot. Here's a good save by me, I think, because I was doing an inspection. You can see 2 of the rivets have come off, but 2 of the rivets are holding it. They lose that nameplate, that's a big loss to them. Something you really can't replace easily. So by catching that, they're able to salvage it and not, keep their eye on it. Question?
Is there a section in the IAR2 that says that the nameplate can be covered with like insulation or jacketing?
Is there a section in IR that says it can't?
Or it has to be visible?
Okay, the question is there a section in IR2 that says the nameplate has to, like prescriptively has to be visible? I don't think I can answer that right off the top of my head. I would say it's intuitive, the idea of a nameplate, that it would be visible. But I probably need to get back to you on chapter and verse if it says explicitly one way or the other.
A lot of facilities, they cover it.
With insulation. Yeah, so the issue, as she rightly put out, is often, I would say hopefully it's less common today than it used to be, but on a low side vessel that's insulated, and if the nameplate was like flat against the vessel like here, that then it gets insulated over. I've seen a lot of facilities like that, and here's what I tell them. If I'm doing like a mechanical integrity inspection or some sort of audit, I say, look, there's no evidence that this vessel has a nameplate to me as the inspector. Now, I don't know that it's not. It looks, the general look and feel of this vessel, the condition of the insulation looks sound. I probably believe that it is a vessel, but I don't know. So I recommend you find it. Unfortunately, that means you have to start tearing into the insulation to start hunting and pecking to find where, okay, it's probably about halfway through the vessel, where's it gonna be? And now you're damaging the insulation. And so then I always put it back in them. Like, I say, look, guys, this is a real issue of risk management, like in the larger sense. Like, one of you folks could show up, or OSHA, and this could be a real big deal, but it's not visible. Or when they show up, you could, on that day, start tearing into your insulation and finding it if you guys made them do it. I understand why, if it was me, where I wouldn't want to start tearing into insulation. I get that, but the bottom line is you don't know for sure. And the real risk to them, I always tell them, if there's a leak from this vessel, let's just say, and then there becomes an investigation, and you're looking into and now you're looking into it, and it turns out that it was not the vessel that you thought it to be, boy, are you going to be in a tough spot at that point, right? You're going to be in a tough spot as the end user at that point. Maybe even you folks too, if you're the regulating agency. So bottom line, you should make plans to get it uncovered. Hopefully, in this day and age, that wouldn't happen now. I think most contractors are pretty good, up to speed. Okay, hey, it's 2:03. Let's take a question.
Sorry.
That's okay.
So when you do a mechanical integrity, when you go through and do their mechanical integrity, if you don't see the plates because they're covered or something like that, what will you do?
I will make yeah, they heard your question. Okay, I will make a recommendation every time. And why? You might say, well, why? Well, because it's Ragagep. So, I mean, if we go back to Bulletin 109, which is like the bedrock of inspections for ammonia refrigeration since the 90s, I mean, the nameplate's like a big part of even that inspection. So, that being said, I won't necessarily make it like, code red, critical, like stop all operations, cease and assist, and you guys are just totally negligent. I don't mean that, but it's a documented finding in the report. It's not correct, and the vessel should be equipped with a nameplate. So, okay,